If you were processing, probably instead of just one pair of gloves, two pair of gloves. The glasses, I usually wear my own glasses, but I come straight from home, so those ones are fine. You shouldn't need them, but better safe than sorry. And also, I'm a super user here, so let's try to be proper. So that's why you have glasses. The hoods, like double covers for the shoes, and that's it. So we're gonna start like the visit, the clean room. I don't know what do you have learned in the course or what you haven't, but more or less you will see that everything depends and relies mainly on the photolithography. So we have a lot of different machines that do different things, but at the end, in order to have like patterns and devices, you rely on having a mask and then doing different things to that mask to have deposit or edge or whatever you want to do to your substrate, but with a mask. So we're gonna start first, like I'm gonna show you like the least interesting, I guess, at the very beginning. So like we kind of finish an upbeat, and I'm gonna talk mainly about the things I do know. But if you see a machine that, oh, that looks cool, and he hasn't talked about it at all, ask me. I might lie, but I will try to be sincere and tell you as much as I know about it. So we're gonna start over there. I just want to show you the room just very, very fast, because everybody probably is gonna talk to you about the cool things that you do with the microfabrication and everything. But I want to show you a little bit one of the problems and the things that happens with is the hazardous materials and the byproducts of processing. So here is what we leave everything that after like we've done it. So like the developers, like you see some chemicals around. Well, today it's pretty empty. Actually, yesterday we had like disposals and a pickup. So probably there you won't see many things today. But here's the room where we put all our waste. So we have a full room dedicated to waste. And I told you at the very beginning that we have the other room that is the bion. So the bion for very harsh chemical processes that like wet etching, that you use HF, hydrofluoridic acid, that it's pretty dangerous and pretty scary. So all that is wet processing is in the other room. Here we do we use machines, so you will see them, and then also photolithography. That's the only kind of wet process that you can use, and cleaning with acetone and IPA, so with solvents. Everything that it's wet processing in the other room. So that's it. I wanted only to show you that. If we were in the other room, we will maybe explain you how scary certain products that we do use are. But if you are interested, we can talk later. But that's it. Now we're gonna go to the characterization area, so microscopes and profilometers and that kind of stuff. Okay guys, so we could say that this is the microscope room. Technically we have 4 microscopes here, 3 electronic microscopes. This is one that it's a standard SEM from Hitachi. It's kind of old, but it works perfectly fine. On your back, behind you, there's another one. That's another SEM, but it can be used also to. We were discussing about the masks and everything. So when you do photolithography, one option that you have is that when you have your photosensitive material, you will see you put it under a UV lamp, and between that you put your mask, so you create patterns in your photosensitive material. The other thing that you can do is just write straight into the photosensitive material with kind of a beam of light or electrons, whatever that ablates that photosensitive material, and that microscope can do that too. There's another third one that for obvious reasons we don't use. It's over there, it's behind you, and you can use like blast from the past. So it's extremely old, we don't use it. And then the 4th microscope that we have here is that one. That's an optical it's an optical microscope, but it's also an optical profilometer. So if you have a sample that you already etch or deposit something and you want to see the difference in heights, you put it under that microscope, and then what that microscope does is like it focuses. You tell the microscope what's the minimum focal point and the maximum, and then it does slices and try to find the things that are focused in that slide, and that's in that slide of focusing point that you're doing. So with that you create a 3D map of your sample. It works fine, but you have to know what it's an optical profiler. So if your sample have materials with very different optical properties, probably it's not going to work very well. If you have features that are very, very thin and there's no light coming out of these features, that's not going to be useful either. On the other room I didn't show you, we have what we call a needle profilometer. As you can imagine, it's a needle that moves, makes lines, and it detects ups and downs. That's it. So here we use it for like characterization of the materials. So let's go to the next room. Okay, photolithography. Check like the lights in the corridor just out of curiosity if you see that from one point they are yellow. Okay, so that's what I would say that probably is the most important room here for like the general users is the room. This is one of the two photolithography rooms that we have, and here's what you kind of prepare your sample. So for the most of you on your left hand side here you will see two spinners. That is those two white things. That is almost like works almost like the same like the pottery spinner that for clay. The only difference is here is like you see the chucks. You put your substrate, usually a silicon wafer. You put it here, and then let me show you. So this one is one of the photosensitive materials liquids that we use. So you place the wafer here, you just put some of the liquid on top of the material, and that just spins, making like an homogeneous layer of the photosensitive material. Then over there's an oven at 90 degrees C. You put the wafer inside to evaporate some of the solvent that thing contains, and then here in this machine is where you actually create the patterns. It has no secret. So here there's a UV lamp. So you put your wafer here, your mask in this tray, you put it between your wafer and the UV line. You put your mask exposed, and then it's exposed. So you will notice that it depends the kind of material that you use, but that one is a positive photoresist. So the parts that has been like hit by the UV light are degraded. So if you develop, they get away. They are dissolved in the development, and it's kind of like developing like black and white pictures. So the parts where you hit the light, they're going to be removed, and you're going to have naked silicon and then on the parts that the light hasn't been like affected by the light, the rubber, because it's kind of a rubber, it's going to stay on top of the silicon, protecting it. So now we can rotate. So if you want to see.
Why do the colors change?
And guys, you probably have noticed that now the light is yellowish. It's because it's the photosensitive material. That light, it's filtered, so there's no UV frequency on the light. So the frequency of this light doesn't affect the photosensitive material. And you can see the bottle, it's even like darker, but if it was a clear bottle here, that shouldn't be affected. So I can leave everything here, and it's not automatically developed by the light that we are using. So that, and you will notice also that the corridor have yellowish light. because we come from that room to the next room where we develop. We don't want that in the walking outside, our wafer gets developed everywhere. So the guys that you haven't seen, that's the machine. As I said, here there's the UV lamp. You put your silicon wafer here, and then in that tray you put your mask that has the pattern. Let me see if there's any mask. I think that there's all ones here. Wait, I have mine. I can actually show a sample of one of the things I'm doing. So that's one of a mask that has, it's a very simple mask, this one. You can see it says holes because it has holes, and you see big ones, but the thing is that the important ones are like 40 micron. So if you go like that, you can kind of see them. Do you guys kind of see? So you put that here, that, and then you put the UV light. And that's another wafer that I already developed with another pattern, and you can see that brownish thing, it's the photosensitive material, and then the part that where the UV light has been touching it after developing, you can see the naked silicon on top of it. So that's it for this room. I'm not going to show you the developing area because it's a cabinet like that where you put chemicals, you put your sample there and you wait for it, so it has no interest. We're going to cross and we're going to show you the reactive ion etcher.
What's that thing over there?
That is another spinner. So the two on the left are like spinners that we use certain materials. If you have to use a one that is not a standard or like the most regular photosensitive material, there's one other spinner here that we put aluminum foil around, so you spin that, and when you're done you just remove it. You have to think that there's plenty different kind of photosensitive materials. For example, on the Bion there's a kind of photosensitive material that is very cool. It's kind of an epoxy. Well, it's not it's an epoxy that it works the other way around. Where the light hits, it hardens, and where the light doesn't, it's just still like liquid, so you can remove it. So the funky thing with that is like you can do very thick layers, so you can create your device with that epoxy. You don't have to process it anymore. You just do photolithography, and then you have your features on that. If your features can be non-conductant, that works perfectly. It's very nice. If you used to use a semiconductor like silicon, then you cannot use that. And here is like, for me, it's like my master is here. You'll see. Okay, guys. So here you can see there's a lot of machines. I'm gonna talk briefly a little bit about all of them, but I would say that that's the main one. I mean, that's the one that I work most of the time. When you work in microfabrication, if it's something like my case or like Kai's over there, you're gonna spend hours in this room. This is a deep reacting ion etcher. I don't know if you heard about it or if you studied it. So remember the wafer that I just showed you? So now you have that wafer with the rubber and the silicon. So what you do is you put it in this machine, and then what that machine does is like the exposed surfaces they got eaten by the plasma. The plasma is a fluorine plasma, so the fluorine ions react with the silicon, and then you can carve onto the wafer. The way that machine works, it's called deep reactive ion etcher because you can do deep trenches, and it's an anisotropic etch. So the way it works is that it works two steps. The first step is like you eat some of the material with the fluor plasma, and then you deposit a substance like Teflon, so you protect the walls of what you just have etched. So you work in cycles, creating like perpendicular walls. If you see in the microscope though, you will see it's a little bit serrated because of those two steps of like deposition, etching, so it goes a little like that. And now Kai, if it hasn't finished, oh, it just finished. Are you gonna do another run?
No, I'm gonna unload it.
Okay, before he unloads it, if you want, you can check the wafer inside. Just take a look. It's a pity because he was using some plasma, so it was like...
You can go ahead and unload the wafer.
Wow. I'm gonna unload the wafer, guys, if you wanna see. But actually I'm gonna unload it, so you're gonna see it here. So that's his wafer. He has a, you see that it's like kind of a mess. That's because he has a carrier wafer and then on top of it he has a sample. And I don't know, let me see if you can see. It's normal that it's broken, Kai?
What?
It's normal that it's broken in the middle?
What's working?
Broken. There's a
Broken. Oh no, it's 2 pieces.
It's 2 pieces, so it's normal. Okay, he has kind of holes too, and if you pay attention, remember the holes that you see? Now they are carved away. If you check, you know, they have some dip. They've been done with the machine. You just want to check. It would have been cool to see the plasma, but anyway.
You think can I see it?
Yeah, go with the camera. There's a YouTube video of me talking about this machine if you are super interested in the machine. See, so that's the sample. And Kai should change his handle wafer because it starts to be very old. Yeah? Okay. Because if he breaks the wafer inside, he's going to be kicked out of the clean room. No, the thing is that those machines are very, very delicate. So they are bound to break. The only problem is that every time that they break, you have to wait like quite a bit. So we try to minimize the time that it's down. But that's it. Okay guys, in the same room, here is the plasma therm. That can work like a little bit like that machine over here, but it always depends on the chemistry. Depending on the chemistry, you can etch other materials instead of silicon. Obviously silicon is the most used one, but depending on the chemistry that you use, you can etch gold or metals or other semi-metals, or also you can use something that is plasma enhanced deposition, so you can deposit materials. So you can do that with machine. That's the BMR, that's mainly for deposit, that blue thing. On the left hand side, that one with kind of a bell, that's also for deposit metals. What you have here is a crucible that you heat it at very high temperature, so the metal like evaporates. So you have your samples on top of it, and the metal vapor goes into your samples, so you can deposit metal. Again, if you have a mask, it's gonna deposit only on the parts that are like unprotected, and then you can do what it's called lift off. So you develop everything, you remove your mask, so you only have deposition on your desired patterns. Another way of doing it is you deposit everywhere and then you etch the gold or the metal that you etch. So that's it for this room. Very fast, I'm not gonna show you. This room, but this room is where we develop the things that I told you. You can take a look, it's what I said, it's just mainly tables, fancy tables with air and everything. Probably you've noticed that the cabin, they have a sash and everything. That it's to be sure that there are no particles getting into your samples. You saw how small were my holes. Imagine like a tiny particle putting there and covering my hole. I'm screwed. I have to do it over, and it's hours and hours. So everything has to be super clean. So the room in general, it's clean, but inside the cabinet it's even cleaner. And also it has two purposes. That thing to make it cleaner, and also everything that we use, it's for example, the photosensitive material is carcinogenic, so you don't want to breathe it. So the sash protects you from breathing like the vapors of that. Here in this room, if you really want, but I understand you see only machines, and I don't know. If you have questions, ask me and I will more. But here in this room, just you can take a look. But there's more, like there's another etcher, plasma etcher. Instead of being deep, that one is called reactive ion etcher. So that only does one step. Do you remember that one was depositing and then etching, deposit? That only does etch. And what it does is that it's like isotropic etch. So it more or less etches in all directions. For certain things, it's good enough. You see two more bells. It's another thing more to deposit metals. And this one is an E-beam evaporator. You have an electron beam hitting your desired metal to evaporate them. That's it. Let me show you maybe the big furnaces, and that's it. I must confess, I've never used anything in this room. But I mean, it's two badass like ovens, no? Like two huge furnaces. Like the group, like the guy that you saw in the other room, Kai, their group work a lot in that. So those furnaces, especially this one, they work in this one. So that furnace, it's like a huge oven where you can control the atmosphere inside and you can do very, very high temperatures. So what they do mainly in this oven is like they almost melt glass in it, and they do kind of very, very tiny bubbles because they kind of suck the air into it. So like blowing glass, probably you've seen the traditional make of making glass, that you blow the glass and you make bottles. So they use exactly the same technique but for microfabrication. So they do very, very, very tiny holes in silicon, and they bond it to a glass wafer, and then they heat the glass like super high temperatures, and then instead of blowing, they suck they put it in vacuum, and there's some air trap underneath the glass wafer, so that kind of like presses the air to make kind of very cool bubbles. You can see on our department, on one of the corridors, you'll see them, and they call it like glass wines and fancy names. But so that's cool. So that's for to do that. That other one, some groups here to research what's the more like trendy material that you can think now in science. Exactly. So here some groups are starting to try to grow graphene into the surface of certain materials. I don't know how they do it. To be sincere, I don't know how successful are they either. But obviously graphene is what gives you money now for grants, so we have to have it. So we're investigating with graphene. Woo! Give me money. So that's it. If you want to see anything else, in the other room, it's another huge badass machines that do all fancy things, but they do exactly the same thing of like the bell machines. So it's mainly evaporating material and depositing. So I would say that that's it.